Coming up on this week's episode of TechSNAP, understanding the difference in different types of RAID can make the difference between a major loss or saving the day. In this week's episode, we'll break down those different types for you and tell you which have worked best in our production environments. All that and more on this week's episode of TechSNAP. Hi everyone and welcome to TechSNAP. My name is Chris and this episode was recorded live on September 22nd for release on September 23rd. My name is Chris. I think I might have mentioned that. And joining me on the Skype line every single week for all 23 weeks is Alan. Hey there, Alan. How are you doing?
I'm good. And this is week number 24.
24, right. Right. You know, it's hard at the beginning of the show, Alan. I got to get my brain in the groove and get everything ready. We got to process it all. Actually, that said, I better step up because everybody's going to have to wear their brain buckle today because, Alan, you are going to school us on some of the most interesting details about RAID, aren't you?
Yep, and we had quite a bit of news to cover on top of it. So it's
we do, and we have a pretty
episode.
Packed roundup too. The TechSNAP Reddit page has been pumping us full of good info now for a few weeks. I love that site, so thank you everyone. Go check that out, links.techsnap.tv if you want to join our Reddit page and submit content to the show, ask a question. That's also a great place to do that. But Alan, you know, with all of the stuff we have to cover today, I'd love to chit-chat. I'd love to keep talking about all kinds of random stuff. But we should probably jump into the news because we've got a ton to talk about.
We do.
All right, well, our first story here is sort of a response to a story that we've covered over the last couple of episodes of TechSNAP. It all goes back to the SSL problems that have been happening recently, doesn't it?
Exactly.
So tell us what this is.
Well, the EFF has had a site they call the Ssl Observatory for a while. We actually talked about it on the very first episode of TechSNAP.
Oh.
Which was a long time ago now.
Yeah.
But what the SSL Observatory does is goes out and scours the internet looking at every different SSL certificate it can find. And part of their findings were that there were a lot of certificates issued for unqualified domain names like Exchange Server.
Right.
With like no .com or anything, or localhost and things like that. Or certificates that were issued that didn't meet the requirements, like not big enough key size or anything like that. So now what they're proposing is to build an early warning system for rogue SSL certificates. For example, with this DigiNotar thing, it went on for about 2 months before anybody figured out what was going on.
Right. Even though they started to suspect at some point and didn't say anything.
Right. So what the plan here is that users would basically anonymously submit copies of every certificate they encounter. So every time you end up seeing a certificate, you would send a copy of that anonymously to the EFF. And they would basically put these in an index and start looking at them. And then if all of a sudden you see a different certificate for PayPal than everybody else, it would send you a warning saying that's probably not the real one.
So this is being driven by the EFF project along with the Tor project. Am I understanding that correctly?
Yes. Well, because if you remember, Tor is one of the projects targeted by the DigiNotar attack.
Right, and they've got to always be, I would think, at least somebody's target, because if you can crack that, then you can catch people obviously doing things they don't want you to know about.
Yeah, and so it would basically work similar to the way Google's Safe Search works, which is built into Chrome and Firefox, where it sends anonymous usage data about the website you go to, or basically what the Google one does is, as you're about to go to each website, it checks it against Google's blacklist. And if it's on that blacklist, you get a warning saying, are you sure you want to go to this website? Because Google doesn't think it's safe.
Right. As our friends over at Twit TV saw this last week.
Exactly. And that prevented a lot of people from getting infected. So it's probably a good thing. So this system would work the same. As people saw the certificates, they would send copies in. And if the EFF decided that certificate was probably a rogue, then you would get a warning back. And
doesn't it strike you, though, as this seems like a weird responsibility for the EFF?
Who else would you trust with to actually keep your anonymous data anonymous?
Yeah, I can't think of anybody. It just seems like I just picture them as like a...
Well, they already had this SSL Observatory project where they're trying to force certificate authorities to be responsible for their certificates.
Oh, okay. I didn't know that.
Right. Again, that's what we talked about in the very first episode of TechSNAP, so it's hard to remember. That was a long
way too long ago. That was way too long ago, yeah.
That was half a year ago now.
Oh, wow. That's like a big moment. It is. It's our 6-month anniversary. Is that what you're saying right now?
2 weeks from now will be.
Wow. Okay. Yeah. Wow. We'll have to keep that in mind.
So, and they found a bunch of authorities that were not following the rules for EVSSL, the ones that turn the URL bar green and stuff. And so they've already had this infrastructure in place. and so they just want to expand it.
I see.
And so the SSL Observatory would gain access to more certificates that they don't always see, like especially ones for internal bans and stuff. But at the same time, it's someone you can probably trust to, because the data is going to be anonymized anyway.
Right. And it's sort of crowdsourced, right?
Exactly. And so this would be a crowdsourced way to detect these rogue certificates.
I do believe this is almost exactly what I was talking about last episode when I said, can't there just be some sort of way to centralize this? And the real point I think we came down to is who could you trust and how do you prevent them from getting compromised? This seems like maybe a solution then.
Yeah, if you make it distributed.
So it sounds like you're kind of bearish on this. You think this could be a good approach?
I think so. And it's a more scalable version of Google's system of hard coding the certificates in the browser.
Right. Yes, exactly.
It's that basically by using aggregate data, you can be like, well, only 1% of the people are seeing this certificate instead of what the other 99% of the people in the world are seeing. So that's probably not the right one.
Right. I love it. It's elegant and it makes sense. It's just based on the trends that you see and things like that.
Exactly.
So any other thoughts on this story?
Not really. I think
all right.
It'll be interesting to see if any browser vendors jump on this.
Right. And, of course, now the SSL industry is still recovering from all of their security issues, but there's one company that seems to never catch a break. And you might be thinking I could be talking about Microsoft. I suppose I could be. But there's another company these days that seems to get their ass beat more than Microsoft does, and that's Adobe, right? I mean, Adobe is constantly now. It's you got to feel for them a little bit because they're struggling to try to get Flash to keep stranglehold on the market, keep Flash relevant, and they keep having issue after issue. And there's been another security announcement from Adobe that it's even going to prompt them to do an out-of-band patch, right? And that's kind of a big deal, isn't it?
Yes, including the out-of-band patch for Android. It's not just for PCs even.
Wow, so we're seeing that these vulnerabilities in Flash are apparently it's a vulnerability that goes across very platforms. Different operating systems.
That's one of the reasons why Adobe's being targeted so heavily, is that when you target Windows, you have Windows XP, Windows Vista, and Windows 7 to try to hit. But if you hit Adobe, even if you hit Flash, even if it's only a vulnerability that works on Windows, you would get all versions of Windows with the same vulnerability.
And now, to make it even easier, we'll throw in Android too. They just throw that in there for you.
And the Mac version. Basically, this had to be updated on every platform.
Wow. Yeah, I'm looking. We have a link to the security bulletin in the show notes, and it's they classify it as a critical vulnerability.
Well, because it can result in remote code execution, which is bad.
Oh, really?
Yeah.
Oh, geez. So
there's no known exploit that is doing full remote code execution, but specifically the way this one is working is it's actively being exploited by sending users emails that trick them into clicking a link that loads the Flash.
Oh, so it's not even like they're taking over the Flash players on websites and stuff.
Well, in this case, they're just phishing users and sending to a site with Flash on it.
I know this has kind of become the show's go-to example, and I apologize for that, everyone, but Stuxnet. Remember how Stuxnet originally, they believe, got into the network? And Stuxnet was a virus to disrupt nuclear operations, and this virus was infected by a Flash file embedded in a spreadsheet. Right?
And actually, that was the same attack that was used against RSA.
Oh, maybe I'm thinking of RSA. Okay. It could be. Yes. I can't remember if that's how Stuxnet was in there. I know one of them was either RSA.
Yes,
also,
RSA
a huge
one
breach,
was
right?
A Flash object embedded in an Excel doc.
I think I must be thinking of them. But jeez, wow.
Interestingly, I had it later in the roundup. Siemens, the company that makes those centrifuges that were targeted by Stuxnet, they're now leaving the nuclear power industry. Part of that is because in Germany, where they're based, the government has decided not to build any more nuclear power plants.
Oh, well, we'll see. Now, the chat room is correcting me and is saying, I know it's Bombers in there, too, and a couple others saying it was USB thumbstick for Stuxnet.
Right, because Stuxnet wasn't actually on, the machines weren't on the internet to try to protect them from this.
Well, that makes sense.
They smuggled it in with good old sneakernet.
So definitely go update your Flash because we're looking at a possible remote code. And I guess, Alan, can you think of any technical reason why they couldn't just load an infected Flash file on a website if they had control of the website?
No, they would definitely be doing that.
So it doesn't have to be an email link to get to take advantage.
So, for example, if you were the guy that took over twit.tv, you could replace the Flash players there with an infected one.
Exactly. Okay.
Very bad news.
So, or what we have seen sporadically happen is bad guys will buy ads in a ad system where people just put their ads on the site and it rotates through and eventually you get a Flash ad and that has
the virus in it. And you get that's how you get a drive-by infection. You're not even
Happens
going
a
to a
lot on
bad
porn
site.
sites, guys. On porn sites.
Right, but that can happen on even with legitimate advertising networks.
It can, but I think the
Usually
porn site
gets
authors.
squashed. Yeah, it usually gets squashed a lot faster on legitimate advertising networks. But
Well, and some legitimate, yeah, exactly. But some of the advertising networks don't really screen that much, and that's sometimes where you'll see some of the less mainstream sites use those guys, and so they're a little more vulnerable too.
Exactly.
So if you enjoy yourself a little internet porn, update your flash. I'm serious.
Yeah.
I can tell by the stats on JupiterBroadcasting.com that about 70% of Flash users are usually one version behind. 99% of the visitors to our site use Flash.
Yep.
So there you go. Even though we offer things in download. All right. Any other thoughts on this story?
Not really.
Did you lose something over there?
Yeah, sorry, my mic cable went flying.
That's all right. That happens to me all the time. All right. Well, I'll set up this next story for us. So this next story.
The one interesting thing was that Android is a slightly newer version of Flash than everybody else. If you look at the version numbers in the security advisory.
Oh, really?
Yes. Android's version is just a couple incrementations newer.
There you have it. Good catch. Good catch. All right. Next story.
Yep.
All right. So this next one is back to the SSL, and it comes right out of the register from the register.com, and it shows that...
This is .co.uk.
Right, register.co.uk, of course. Researchers have discovered a serious weakness in virtually all websites protected by Secure Socket Layers protocol, according to the register.
Yes.
What the heck, Alan? Are you trying to scare the crap out of me again?
Yeah, a little bit.
Great.
No, this attack isn't all that practical, but it's something that, the average person doesn't need to be too concerned about it, but
is it
people
like
that
one of those
build
attacks?
These systems,
That somebody who's extremely motivated would be able to take advantage of?
Kind of. So basically, SSL 2 and 3 and TLS 1 are all vulnerable to this attack.
Oh, wow.
Now, SSL 2 isn't really used anymore. There's a couple sites that still support it, but
it's something that's affected it all the way back. I mean, that's kind of
in our tests, PayPal, Google, Facebook, Hotmail, etc., don't support SSL 2 anymore.
Oh, okay.
Because of previous problems like this. The other thing is that TLS 1.0 is what's used mostly, but there are newer versions, 1.1 and 1.2, but they've just never been adopted.
Huh. Why?
It's kind of a chicken and egg thing. Libraries like OpenSSL and NSS haven't implemented them because no browsers have implemented them.
So,
if no browsers use it, no servers are going to use it. And if no servers use it, no browsers are going to use it.
What's the vulnerability here? What are they able to do with SSL?
So basically, when they're in a man-in-the-middle position to be able to sniff the traffic going back and forth, they can use what's called a chosen plaintext attack against the AES encryption algorithm that's most often used by TLS.
So
basically what they do is they have this attack called Beast that basically, by using an iframe or an ad or just injecting code into the target website, they get this bit of JavaScript to run, which basically sets a cookie where they know what the text of that cookie is going to be. So then when they see the encrypted version going back and forth, they know what to look for.
Huh.
And they can do cryptanalysis against that and try to break the encryption.
So does this then make it so like DigiNotar, how the Iran government was able to use the DigiNotar's keys to essentially spy on people's SSL traffic? Does this just sort of even take the need to get their keys? Does this just kind of take this out? And now if you're just sitting in between like every single ISP in the entire internet is, you can just sit here and sniff this stuff.
Possibly. One of the problems with this attack is that it's slow. It takes quite a while to
Yeah, what kind of
brute force
CPU
through it.
power are we talking about?
Quite a bit. And also, usually it only decrypts part of the message. Like, you don't get all the traffic. You would just get their login cookie, which would then allow you to, for example, use their PayPal account.
So it says here, like they give an example in the article. They say, at the moment, Beast requires about 2 seconds to decrypt each byte of an encrypted cookie. That means an authentication cookie of 1,000 to 2,000 characters long will still take a minimum of a half hour for their PayPal attack to work. Nonetheless, the technique possesses a threat to millions of websites that use earlier versions of TLS.
Yeah.
So I guess you wouldn't be able to necessarily do it in real time, but you could sort of collect and then background analyze.
You would have to hope that their login cookie at PayPal didn't expire within that half hour.
Yeah, totally. Right? Yeah. So I guess that's for an example, like some places will even say it like in the checkbox, leave me signed in for 2 weeks. I can't remember what site I use frequently that does that. Maybe it's Google. But so in that scenario, if they could capture, store, and then analyze, they'd be able to come back within a 2-week time period and get access to the Gmail account.
Exactly.
That's pretty creepy.
And so basically, with using that known plaintext, they can actually try to decipher what you're sending. Now, not all SSL and TLS implementations default to using AES as the encryption method, though. In particular, OpenSSL, in its list of preferred ciphers, the Camellia cipher is first.
Okay.
So, for example, when I go to one of my websites in Firefox, because the server prefers Camellia first, it actually uses that instead of AES for the encryption.
Oh, okay. Okay.
So that would, again, that might make it this attack not work. The thing is, if they're in the man-in-the-middle position to be able to alter the traffic, they could change that list of ciphers the server was offering, or that the client was offering, and basically trick both sides into agreeing on AES 256.
Because it could claim like, oh, I don't support that, so you have to do this.
Yes. So basically, the way SSL works is when the client connects, they send a list of the ciphers they support. Then the server compares that to their list and picks the strongest one that is supported by both sides.
Ha. And then, of course, you just...
Well, actually, it's not
a matter of tricking them, really. It's a matter of tricking if they don't respond with the version of encryption you want.
Yeah, and it's not necessarily... They're not necessarily in the order of the strongest to the weakest. It's a preference list.
Ah, right.
And,
of course, that makes sense.
A little bit
Whatever
later down in the
administrator
text
says.
here, I did some analysis on the preference list of a number of different websites, and it was interesting to notice how every site I looked at had a different preference list. But part of that could just be what SSL acceleration hardware they use in front of their web servers.
You did a fair amount of testing, right? Didn't you? Didn't you run
Yes.
some tests against this to kind of find this out?
Yeah, I did. I stayed up too late last night playing with this.
And you're probably going to have all of the results in the show notes, I'm sure.
Yeah.
Which is...
So the researchers have been working with the browser vendors since about May to develop a solution for this problem.
Okay.
But every time one of the browsers comes up with a proposed patch, they find out that it breaks compatibility with some major SSL implementation somewhere.
Oh, really? Okay, so
which
this
would
is something they've
result
already been
in a number
struggling
of-
with.
Right, and result in a number of major sites not being reachable over SSL after the patch. So thus far, they don't have a solution to this.
I hate it when you say that.
and part of that could be that, there's a number of different of these SSL implementations out there, right? Like I'm sure that, there's one patch that would work fine with OpenSSL, and that would cover most standard Apache servers and so on. But then, a lot of big corporate sites have these load balancers or SSL offload machines that do all the work. And they sometimes have more stripped down implementations or
Very
just custom
basic,
implementations.
Yeah. Right. Yeah, I've seen that, especially where it's locked down by what you license, so you can get different features, but you have to pay them on a yearly basis to have that package added and then support it. It sucks.
Yeah, so just some cliff notes from my research. I have the full list of all the ciphers for all the different sites in the show notes. But PayPal defaults to AES 256. That's the one they prefer. So unlike your regular OpenSSL, they don't default to supporting the Camellia cipher.
And so is that by default the OpenSSL? Is that what OpenSSL just goes with his?
As the its preference. It's at the top of the list.
Okay. So then they're probably not using OpenSSL.
Right. Or, even if in their backend they were, their acceleration appliance in front of that doesn't. Interesting, Google uses a slightly weaker one. They use RC4 with SHA.
Really?
Now, if you don't support that, it defaults to RC4 with MD5, which is even worse.
Yeah.
If you don't, so if you say no RC4 at all, then it does AES 256.
Why would they do that?
Likely performance reasons. It takes a lot less CPU time to do the RC4
They're
version.
insane about speed.
Yeah. And,
okay.
It's not online banking. It doesn't necessarily have to be as secure.
Yeah.
At first, when I saw that, I was testing Google Docs because that's happened to be what I was connected to at the time.
Sure, yeah.
So I was wondering maybe they use more secure ones for like Google Gmail.
Or your login session or something.
Yeah. But it doesn't appear so.
That surprises me, to be honest
It's still
with you.
256-bit. Or sorry, no, it's 128-bit even. Sorry. Which is still strong enough, but it's just interesting that their preference list is almost upside down of most other sites.
Yeah. I guess maybe they also do it for mobile devices, potentially.
Possibly, yep.
That could
make a speed difference on a mobile device for sure.
Yeah, and maybe mobile devices, depending, especially some of the older ones, like early Android phones, maybe don't have support for some of it or something. Who knows, right? Maybe they have more limited
Yep. And then, interestingly, Facebook has, again, they prefer that RC4, but with MD5, they prefer basically the weakest one first. Again, likely for performance. And honestly, for Facebook, it's probably not that big a deal. But then when you don't allow RC4, they default to AES 128 first, not 256. So they have the ciphers in a strange order. And then Hotmail starts off with AES 128 and then goes to 256, and then a bunch of other ciphers.
So if they start at 128, isn't that what most stuff is just going to go with? Oh, okay. Here we go.
Yeah. Yeah. Well, because the server picks, not the client.
Interesting that both Hotmail and Google are using 128-bit encryption. And maybe it's for the same reason.
Interesting was that Facebook's private key for their SSL is only 128-bit, or 1024-bit. Where when you buy a certificate now, most all certificate authorities require 2048-bit at least.
Huh. Boy, we're getting really geeky here.
Their certificate is from 2009 and expires at the end of this year. So they, they'll
probably renew it. Yeah.
So they'll definitely renew it. So maybe the new one will be stronger.
Yeah. There you go.
And then I have the results against my server, which is OpenSSL, with only the high ciphers turned on. And so it does Camellia 256, and then Camellia 128 before AES 256.
Good.
And again, that's just, honestly, I prefer it wasn't in that order.
Really? Even though the first
I want all the 256s and then all the 128s.
I see.
But
that makes sense.
Most people are either going to support Camellia 256 or not, and then fall back to AES. So it's not very likely somebody's going to hit that middle one anyway.
Yeah, true. Any other thoughts on this one?
Yep, and then we have a link to an additional article that explains a little better than the main one. And another interesting thing from the Register's article was that they found that about 35% of the SSL-enabled sites they surveyed were still vulnerable to the SSL attack from 2009, which is the one about SSL v2 and a couple other things like that.
Go figure.
Some sites have been purposely delaying deploying SSL changes because they're concerned that outdated browsers might not be able to reach their site over SSL anymore.
Hopefully with Chrome taking off so well and IE continuing to drop in market share and Firefox...
Well, specifically IE6 is the one you have to worry about, or even older.
Hopefully that cow just dies. So sick of IE6.
Yeah. But, if you're an e-commerce focused site, you might not want to prevent certain users from
I don't want to sell to those people. To be honest with you, I don't want their money. No. I don't want IE6 users' money.
They're going to be more trouble than they're worth.
Yeah. They'll just come around and stink up my site. All right, you ready to go on today?
Yes.
Just kidding. You ready for the next story? All right. Yes. This one really, I'm glad you threw this one in here because this one really
I'm really excited about this one.
Yeah, okay. All right, good. All right, so the next story is Real VNC. You guys probably have heard of VNC before, right? Anyways, the guys over at the Real VNC project, or company, I guess, are demoing a BIOS-based VNC server.
Yes. Now, they work with Intel to integrate this. So Intel has this technology called vPro, which a bunch of my servers actually have.
Yeah.
And it allows me, basically on the onboard network card, there are actually two separate MAC addresses. The typical one and then a management one. And basically in the BIOS, I have to enable that, assign an IP address or enable DHCP, and assign either a password or a certificate. Mm-hmm. And basically using that, I can connect to the machine, turn it on and off, query what hardware it has and the state of that, and a couple of basic things. Now, different versions of that have different features.
Right.
Mine, I'm able to see the BIOS boot screen.
I love that.
But not interact with it. So it's not great.
Is that like a tease? Like, hey, if you want to pay us a little more money, you can get interactivity.
I can read the error message so I know what spare parts to bring, but that's about it.
Why would you do that?
Because it would require a bunch of extra hardware to be able to control it.
Okay.
So the more expensive motherboard has the feature.
Yeah.
So with this Real VNC, you would have full access.
I like this.
So you'd be able to get into the BIOS, change stuff, mount remote media, so you could reinstall the OS on a server or a computer remotely, or boot it off a live CD to fix it and things like that. And it's all secured by the existing encryption system in the vPro chipset.
Yeah, and that was I think one of the first questions I had was, well, what about the security of this thing? But,
Yeah.
you know.
Well, there's a
Okay.
couple of points about that.
Okay.
Specifically, the vPro wouldn't be enabled by default. You'd have to
Okay.
enable it.
Okay.
And you'd have to assign it an IP address and either a certificate or a strong password. And it's actually very picky about that password.
I
It has
bet,
to be,
yeah.
like at least like 12 characters long. Like it's not even just your typical website password stuff.
Okay.
And so it's not like people are going to have their computers unintentionally remote controlled
Right.
because of this feature.
Right.
It's off by default. You would have to enable it and configure it before it'd be usable. But once it is usable, you could basically you get all the features you get from like an expensive IPMI module for a server.
Right, like you actually get to watch this thing post and boot up, right? I mean,
Yeah, you
that
can interact with it, and you can install the OS on it remotely. Now,
I have used
everything.
like you just mentioned really expensive IPKVM systems where you would get this little dongle you'd plug into the monitor port, and you get you get one USB plug, and then an Ethernet plug goes in the bottom of that dongle, and it gets an IP address, and then you go to a web browser and you can connect to it, and you can attach your local USB media as a CD-ROM on the remote server and all that kind of stuff. But the problem is it costs like $10,000 just to get the hardware.
Yeah, the device to do 16 computers with that is about $16,000.
Yeah.
Plus more for licensing if you want more than one person to be able to use it at a time.
Right. Good point.
And the cables cost $100 a piece.
Each. Yep.
Yeah.
Yep. Yeah.
And,
but it's awesome.
Yeah. Now, some like Dell and HP servers and Supermicro servers will have IPMI, which would just be an Ethernet interface that will provide that same functionality. Basically, the entire IPKVM part is built into the chip on the
NIC
on a card,
the NIC or whatever. Yeah.
And
that'd be
it's
really
like
cool.
integrated with the BIOS. But again, that's rather expensive and only available for servers.
Yeah.
This would allow you to do it for desktops.
I like.
So
this.
even imagine like a corporate environment with a bunch of scattered offices. You could have one central IT department where they would have, almost complete control of the computers with this vPro technology.
Yeah, and plus think about all the awesome security exploits that we're going to talk about that'll happen with it on TechSNAP. Tons of stuff to talk about, I'm sure, from this.
Well, you have it set
Eventually
up
somebody's going to crack this thing. You know it.
if it's on a private LAN so that it's not exposed to the internet.
Oh, for sure. Yeah.
And
But
it's configured properly,
some
including
dope-
using certificates.
some dope is going to put it on a public IP address, and then somebody's going to get BIOS level access to his machine, and we're going to have a good laugh at it because it'll show up on our TechSNAP Reddit page.
But I for one welcome this technology.
Oh, absolutely. Oh my gosh.
So it's available right now for Intel Q67 based motherboards.
Cool. I've got a link to a video that you threw in the show notes that shows a hands-on demo with it from an Intel product guy. They've also got a few shots of an action. This is a pretty good write-up that Engadget had here, so that's pretty nice.
Yeah,
Any
I
other
just said
thoughts on
that my servers are based on the Q35 motherboard.
Oh, you just missed it, Alan. You just missed it.
Well, no, it's basically only the newer Sandy Bridge processors, and mine are the older Core 2 Duos. So it's 3 chipsets behind. But
They always manage to throw a few carrots in there. They want me the next motherboard. I want to get me the next motherboard every time. Any other thoughts on this story?
no.
All right, sir. You know what that means. It's time for the TechSNAP feedback. It's time for the TechSNAP feedback, but you already knew that from that lovely music that's playing. Now, in this week, we're continuing the feedback topic of home server setup. We've been walking you through the steps each episode. We're spreading this out a little bit. And in this episode, we're going to address the all-important topic, storage and RAID in particular, because, of course, you don't want to lose any of your epic goods that you store on your home server. So, Alan, you're going to walk us through various types of RAID setups, including a few pretty fancy ones, aren't you?
Yes.
Now, I warned everybody, you need your brain buckle this episode, and that's true, especially for this segment. If you get lost a little bit, just jump back over to our show notes over at jupiterbroadcasting.com. Look for TechSNAP 24 in the show notes. On the links on there, you'll find the show notes where Alan has a lot of this written out, and then also linked to further resources. So, but we thought, if you're going to build a home server, you probably want to protect your data. And we're going to talk about some ways to do that in Linux Action Show. But Alan, you're going to talk about good old-fashioned RAID.
Yep.
So lay it on us, sir.
So basically what RAID is a set of technologies that let a bunch of independent disks act as if they're one logical disk.
Redundant array of independent disks?
Yeah.
There you go.
And so in the first type of RAID, RAID 0, which is called striping, you basically have 2 or more disks and then as you are writing the data to them, you break the data up into blocks, usually about 64 or 128 kilobytes. And the first block goes to the first disk, and the second block goes to the second disk, and then back to the first and second, or depending how many disks you have, it just gets spread out. So that means if you write, say, 10 megabytes of data, it's getting written half to one drive and half to the other drive. So that means both drives are writing at the same time, meaning that you can write that data down twice as fast.
And
So
then
so
if you're writing it to two different drives, how does it recover if one of those drives fails?
it doesn't. That's the problem with RAID 0. So you get extra performance because you have more disks reading and writing the data. But
And you know what? To be honest with you, I do RAID 0 on my gaming machines. Really, and now I just go SSDs. But for just like I want the zones to load fast and stuff, you could notice a difference if you RAID 0, just even in a desktop.
Yeah, and and the other advantage with RAID 0 is there's no loss of storage space.
Right.
However many disks you have, you get that number of disks, n, times the smallest of those disks. So if they're all the same size, you get the full capacity of all your drives. So yeah, while you're reading and writing, you have multiple physical disks doing the work, and so it happens faster.
And and you really see it, because if you can read from two drives at once, oh boy.
Yeah. So the disadvantage is that there's no redundancy. If one disk dies, you've lost half your data, and it's every other block, so all your data is basically destroyed. But a common use case for RAID 0 is something like video editing, where you need that really high throughput.
I should have mentioned, actually, the machine we're recording on right now has two 10,000 RPM hard drives in a RAID 0.
Yeah. And so you have additional speed from those drives just being 10,000 RPM plus RAID 0 just so that you can achieve the read and write speed you need to record edit.
The video we're recording right now writes to the hard drive at 170 megabytes a second. So you really have to have some...
A regular 7200 RPM hard drive can manage, if you're writing in a straight line, like 100 megabytes a second, but not 165.
No, and you can't have it. You have to have a little bit of overhead, right? Because you can't have it slow down, or else you lose frames. So you gotta let it maybe have some overhead for other processes to hit the drive from time to time.
And if anything else touches that drive, then you cut your speed in half, and it gets really bad. Yep. So the next other type of RAID is RAID 1, which is called mirroring. And basically, in this type of RAID, every block that gets written to the first hard drive is written identically to the second hard drive. So both disks contain exactly the same data. So the total size of your logical drive is the number of disks you have divided by 2.
Yeah. So
the number of disks divided by 2 times the size of the smallest drive. So you only get half the storage.
Yeah, you get half the storage. But there's a hit with writing in performance, but there's an improvement with reading, right?
Right. So writing is usually about the same because both disks have to do it. Now there can be a small hit because you have to wait for both to finish before you can continue.
True.
But yes, when you're reading back, you get double the read performance because you can have two heads working.
One point to mention, you mentioned how you sometimes have to wait as it writes before you can continue. This is where sometimes desktop level RAID controllers will go wrong. And they're just not, sometimes they're actually just kind of software-based RAID controllers, and they actually use your CPU to do some of the math for RAID, and they will slow down on the writes here in particular for this kind of stuff. So if you notice after you've implemented RAID, that it just takes forever to copy files around and stuff like that, it could be that you don't have a very good RAID controller.
Yep.
All right, so that's RAID 1, and that's, honestly, RAID 1 is like a real solid solution if you've got two hard drives in a server and you just want to have redundancy for one of them to fail, right?
Yeah, and so when one of the two disks does fail, the other contains exactly the same data, so all you do is pull out the dead drive, pop in a fresh one, and through a process called resilvering, all the data from the good drive is copied to the bad drive, the new drive, and you're back to a healthy RAID array.
Yeah.
So yes, RAID 1 can improve your read performance because you have twice as many heads doing the work, but it's not going to help your write performance. It may have a small impact on it.
Right. Usually does a little bit.
The main disadvantage of RAID 1 is that you lose half your storage capacity.
Because you have to have that in there for parity. You have to have the space for the parity.
Well, it's not even parity. It's an exact duplicate.
Yeah. Oh, right. Yeah, right.
Yeah. We'll talk about parity in a minute.
Right.
And RAID 1 is typically used on systems that require really high fault tolerance. Right? You're not worried about how much storage you need or how many hard drives you need. You just need this server to be able to keep going when one of the drives dies.
Right. Hold it together just long enough so you can get something in place.
Importantly, the system is still usable while as long as one of the disks in the mirroring is still working, the system's still usable.
I'll tell
So
you,
if you
like,
set up, if it's a really important system, you could have 4 copies, identical copies of everything. And if 3 of those disks die, as long as one's still working, it's still running.
right. Yeah, web servers, where you just have like a real basic page on there and you don't want to look, you don't want to go down. That's a good example. Or domain controllers for a Windows network. You don't usually need a lot of disk I/O. You just need it to be up so people can log in the morning. RAID 1's a great solution.
So that's why you want like double power supplies, double hard drives. Just remove that single point of failure.
Okay.
There are other types of RAID, like RAID 2, which currently is not used. Basically, the RAID 2 idea was it was a way to do the striping, but such that it was done at the bit level. So you would have a number of drives where the heads be working perfectly in tandem, and you'd be like, treat it as if it was one big physical drive almost.
Okay. Yeah.
And so they would have the same addresses for the bits, but basically because the controllers don't quite have that level of control over the disks, and because it has some other problems, it was only ever theoretical. So it's never actually been used. But if it did work as it was explained, it would have been really fast.
So they kept the RAID 2 like designation assigned to it, but they just moved on.
Because somebody came up with it, but nobody actually ever built it because of
that makes sense.
Physical problems.
I remember hearing that a long time ago, and I'd always kind of just never really paid attention to the fact that we never use RAID 2.
Yeah. And RAID 3 is similar to RAID 0, but instead of using those blocks, it does it for every byte. Now, the problem is that most drives are limited in the number of input-output operations they can do per second, or called IOPS. And so by doing it in such small chunks, instead of even like the 512-byte sectors of the hard drive, you're killing your performance. And more importantly, if you try to access more than one file at a time in a RAID 3 array, the performance just goes out the window. So RAID 3 is rarely ever seen anymore.
I see a lot of RAID 5, though.
Yeah. RAID 4 is basically identical to RAID 5, except for the parity information is always specifically on one disk.
Oh, really? That seems like a single point of failure that would be kind of counterproductive. Like the whole point of RAID,
well, no,
right?
because if you lose the parity disk, you can just recreate it.
And I guess you could always have your parity disk be a RAID 1 disk somewhere, right?
Yeah. We'll talk about nested RAID in a minute.
Okay. I'm getting excited, Alan.
Yep. RAID 5.
Yeah.
This is one of the most common ones. So it basically combines the idea of RAID 0, of your striping, with what's called parity. And so when you write your data, you break it up into as many chunks as you have hard drives minus 1. So in this case, we have 4 disks. So your data is broken up into 3 chunks. And one of each of those chunks is written to each of the hard drives. And then the 4th drive gets basically what's called a parity block. And that is basically a checksum of the 3 values. So basically, it adds all 3 of those numbers together and then writes it down. So now if, say, disk 1 in this diagram were to die, you would then have A1, A3, and AP.
Right.
So if you took AP, subtract A1, and subtract A3, the number that's left would be A2. So you'd be able to figure out what was supposed to be on the missing disk. And that's so that you could, the controller on the fly can figure that out. So even when that disk is broken and hasn't been replaced yet, the controller can figure out what was supposed to be there. But it'll be slower than having the actual disk.
Yeah.
And then so once you replace that broken disk and the resilvering process goes through and rewrites all the data that's supposed to be there, then you're back to your full performance. The other thing RAID 5 does is it staggers those parity bits. So the first pass, it's on disk number 4, but the next pass is on a different disk and a different disk.
So lets them continue to chew on it, so that way they're not getting hit up. They're not hitting like bottlenecks on the I/O.
Right.
Throughput,
So it's not one disk that's always getting the parity.
Right.
So that
that too.
where you're doing the parity calculation is spread out.
Okay.
So that you have more even performance. Because and that was why RAID 4 isn't used. Because in RAID 4 you put all the parity information on one disk. So that one disk is always going to take longer because it has more complicated math to do. Instead of just writing the data down, it has to calculate this chum and do it all and then write it down.
Right.
And the problem with that is if you're writing a lot of data at once, you don't want that drive to get behind. So by spreading it out, So by spreading it out like RAID 5 does, you get better performance.
Yeah, absolutely.
The other advantage with RAID 5 is your total size of your logical disk is however many disks you have minus 1 times the size of the smallest one. So you lose 1 disk to parity.
Yes.
Unlike mirroring, where you would lose half the disks.
Mm-hmm.
So you get the fault tolerance you would get from mirroring, the ability to lose one drive without the array being deleted.
And so if you have 3 drives, you essentially get the storage capacity of 2 drives.
And if you have 5, then you get 4, and so on.
Right. It's easy math to kind of do in your head, so you know. All right. Well, if I want to have a terabyte of storage, I need to buy 3 500 gigabyte drives, or something like that. No.
Yeah.
Yeah.
Yes, that would work.
Okay.
And if you want 2 terabytes, then you need 5 500 gigabyte drives.
Right. Yeah. And I was just working on a machine on Monday, I think, that has it's an Ecologics box that I think it has 16 drives in it, and they're these SAS drives. They're like laptop hard drives, but they're built for servers, and it's just loaded full of them, and they're all in different types of RAID setups, and it's pretty intense. And a lot of these are designed where you can pop the drive out in real time on a server system.
Yes.
So you don't have to shut the system down. You just walk up to it, hit the little thing, and whoop. Now I try to avoid doing that, but you can do it.
And see what happens is when one of those disks is broken, the RAID array runs what's called degraded mode, where it's doing the math to figure out what's supposed to be on that disk because that disk isn't available, either because it's broken or because you've pulled it out or whatever. And then when you put in a fresh disk or put the disk back in, it resilvers and basically gets it back to what it's supposed to contain.
Right.
So RAID 5 is typically used in servers where you need a large amount of storage and performance, but you need some fault tolerance as well. Mm-hmm. So you get the speed of striping and the fault tolerance of basically mirroring. Not quite as good as mirroring because you don't have a duplicate of every single drive, but you do have enough that if one drive dies, you're still going to be okay. As long as you replace that drive before another drive dies.
Is it just me, or does it seem like really we got to RAID 5 and we kind of stood there for a few years and people were like, all right, well, RAID 5's good, but then it seems like all these different RAID technologies just took off. I don't know.
But the problem with RAID 5 is if 2 of those disks die, then you lose everything.
Ah.
So say disk 1 dies, and even if you replace it in time, and while it's resilvering and populating all the data on that disk, if then disk 2 dies, your entire array is gone. All your data is gone.
Yes. So if you had a bad day and you lose 2 drives.
Yeah. And if all your drives are identical, which is the typical configuration, there's a higher chance that if one of the disks dies, then one of its identical brothers is going to die too. Mm-hmm. Or very soon, anyway.
Yeah.
So that's where RAID 6 comes in.
Oh, RAID 6, okay.
So what RAID 6 is just RAID 5, except for there are 2 copies of the parity.
There we go. Now we're talking.
So your usable size, your logical disk, is the number of disks minus 2 times the size of the smallest one.
Right, because you have to accommodate for losing 2 drives.
So in this case, they have 5 disks, and you get the storage capacity of 3.
Wow, huh? How about that? Does that blow your mind? Think about that. And these drives are not cheap generally either. No.
Although if you're using fancy RAID to get more performance, you sometimes can get away with cheaper disks. But usually if you need it, you're not. You're doing the most expensive disk with this technology to make it even faster.
Yeah.
So with RAID 6, again, it's the same as RAID 5, except you have 2 parities, and they're spread around, again, on purpose. And so this way, even if disk 1 dies, and while you're replacing it, disk 3 dies as well, you can still figure out what was on both of those disks and get them back up and working.
The chat room's asking how long it usually takes to resilver a hard drive, but that really depends on the size.
That depends on the size of the disk and how busy the RAID array is and how good the controller is.
Yeah.
But if you're reading and writing to the array a lot while it's trying to do it, the disks that contain the bits it needs to calculate the parity take longer. So if the system's offline, then it's usually fairly quick because you're just basically filling up the hard drive.
Some of a lot of these RAID controllers have like RAM on them, like actual RAM on them that they will cache to first to try to speed things up.
A typical controller has 256 or 512 megabytes of really fast DDR3 RAM on the controller to buffer stuff and to basically to supplement the usually 32 megabyte buffer on the hard drives.
And then also a lot of times
they'll have a battery backup.
Yeah. So that way, if the server loses power, they can finish writing and
they have enough time. They can keep the data alive long enough to finish writing it to the disks. Yeah.
I love it. It's cool. So I'm sorry, I didn't mean to interrupt RAID 6.
Yeah. So in RAID 6, if any 2 disks die, you're still okay. If a third one dies, then you're out of luck. But then you've lost more than half your disks already. So you're going to be in trouble anyway.
You probably just had an earthquake. Maybe a tsunami came in and destroyed all your data.
Yeah. And so RAID 6 is typically used in servers where you need lots of storage and lots of performance, but you also need that critical fault tolerance.
Right. Absolutely.
And RAID 6 also requires rather expensive hardware controllers.
Mm-hmm.
Most onboard controllers can't do RAID 5 because that parity calculation is a lot of work. And like you said, that's up to your CPU if it's an onboard controller. And so RAID 6 is usually just right out unless you have an expensive controller card.
Right. Yeah, one that you probably get with a whole server setup.
Because you're losing 2 disks, usually it only happens when you have a lot of disks, right? There's not much sense to use RAID 6 if you only have 4 hard drives.
Right.
Because then you'd be better just doing mirroring, right? So you would get the same capacity and less work.
Yep. Yeah. So if we're not going to do RAID 6, what's after RAID 6? Because I thought it stopped at 5, Alan. How's this work?
RAID 6 is where it stops. Now,
okay.
But there are more complex controllers that can do what are called nested levels of RAID.
Right.
Yes. So the first example of that is RAID 0 plus 1.
Mm-hmm.
Now, there's also RAID 1 plus 0, but they're basically the same idea. And so basically what this means is, do you have the diagram?
I do.
There it is. You're doing a RAID 1, which is mirroring, across 2 RAID 0 arrays. So you have your RAID 0 arrays provide you with the high performance, and then you're doing RAID 1 across them, or mirroring, so that you still get the fault tolerance. So you get the fault tolerance, but you also get even more read speed.
I love
right? Because RAID 1 provides you the extra read speed,
right.
and RAID 0 provides extra read speed.
Yeah.
So basically, when you're reading, you're using all 6 disks at once.
Oh, man.
But you don't lose as much capacity as you would if you just did RAID 1 for this.
Mm-hmm.
So you gain extra write performance and double extra read performance.
This is great, and this is the setup that I've used on like that Ecologix box and the EMC boxes for VMs. It's great for VM hosting.
But again, you're only getting half of the storage capacity.
Yeah, you pay for it, don't you?
Yeah. Now, RAID 50 and RAID 60 are even more complicated.
Oh my goodness, I've got them ready. I got the diagrams ready.
Yep. So with RAID 50 and 60, basically what you're doing is RAID 0, which is striping, across 2 or more arrays of RAID 5 or 6. So you have your RAID 5 array for your fault tolerance, and it's already striping. And then you're striping across multiple RAID 5 arrays.
This is so baller, I gotta say. I love this.
Or again, you can do this with RAID 6 for additional fault tolerance. Now, one of the other reasons why this kind of setup is more common than you would think, right? Because you could just do this with one really big RAID 5 array. But sometimes when each of your controller cards only has so many drive ports. But also, if you're doing fault tolerance, you have to consider one of your RAID controller cards dying.
True.
And so by using RAID 50 or RAID 51, RAID 51 would be mirroring a bunch of RAID 5 arrays. But basically, using each of these RAID 5 arrays would be on a separate controller, which would then be working together in a RAID 0 array.
Mm-hmm. Mm-hmm. This is a really great. Alan, I had completely forgotten about how fundamental it was when we were designing some storage systems, how we went full out. We thought of, the redundant power, and you had to consider controller failure too, because, it's not just drives that fail. It's the actual components in the server too.
There's components of any kind of thing can fail. Mm-hmm. Now, that's a hard one to work around unless you're doing, but if it's, absolutely imperative that machines stay up no matter what, then you'd want to do something like RAID 51, or if it's that important, RAID 61, where it'd be a mirror across multiple separate RAID 6 arrays.
Right. Wow.
Or you can get into more complicated things like having multiple replicated SANs.
Yes.
So you have separately physical machines with different arrays in them. But
and I've also experimented with things like using the Linux DRDB system where I have a mirrored drive on a server, and then I have a duplicate server that's its hot standby that has a mirrored drive, and I just use DRDB to just replicate data between them all the time. So if the drive fails, I have just a hot standby entire server that I fire up. And
exactly. There's a similar system under FreeBSD called HAST, H-A-S-T.
Okay. And I kind of find that I kind of find with virtualization and being able to move equipment around so much that almost that approach now is becoming more important than centralized storage.
Yep.
But when you need a lot of storage, and you want,
a lot of the ability to move virtual machines between physical machines usually relies on having external storage,
right?
And that external storage is going to have things like
it's going to be
it's
something
going to have RAID 50 or 60, like or RAID 5 or 6 at least.
probably implemented at the hardware level, so you don't really. And that most of the time in the real world implementation, when you really see these kinds of things, you generally are setting this stuff with some sort of hardware controller, and then you're attaching it to the operating system, and it just shows up as a single disk or whatever you have it provisioned as to the operating system. So it doesn't, it's not like Windows or Linux is necessarily aware of all of this configuration, and that's good because then the operating system just writes to it like a storage device.
Yeah, and the controller can decide how it wants to lay it out on the disks.
Yeah, and then it's using the hardware accelerated math for figuring out all of that. So it doesn't put the impact of the performance impact on your own server. But that's like you said, that's thousands and thousands of dollars. In a little bit in the Linux Action Show, we're going to talk about how to do something like this under Linux using software. But I don't know. I guess I'll talk about it more in Linux Action Show. But I'm still a fan of implementing all these kinds of things in hardware whenever possible.
Yes, but if it's just for your home server, you may not. And if you just want to experiment with it, it's not necessary to go out and buy a really expensive
the stakes aren't as high then.
Exactly.
It's not your job on the line.
Yeah.
When it's the job on the line, it might go hardware.
Exactly.
So we don't have diagrams for RAID 61 and RAID 51, but how would they differ from what we're seeing here necessarily?
Basically, instead of a RAID 0 at the top, it would be a RAID 1.
Oh, okay.
So you'd be mirroring. So you would lose a lot of capacity there. In this case, you have 9 drives, and you're getting the capacity of 6.
Wow. How about that?
If you did RAID 1 on that, you would have 9 drives, and you get the capacity of 2.
Yeah. Wow.
Yeah.
That'd be a big loss. Yeah, it's pretty funny, isn't it?
Yeah, but with that RAID array there, you're getting huge performance because you have these RAID 5 arrays, which are already giving you decent striping performance, and then you're striping across 3 of those. You're going to get some pretty sick performance. If just for simple math, you assume each of those disks can handle 100 megabytes a second, then you have 600 megabytes a second of write speed there.
SSDs now, of course, that's more expensive than SSD, but you see, you can do it. You can get that fast with traditional drives. It's true.
Yes. Now, I've seen a review somewhere where they were pitting 16 10,000 RPM SAS drives across 2 separate RAID controllers versus like a pair of SSDs.
Oh, really?
Or maybe it was even just one SSD. It's like how big a RAID array do you need to compete with one SSD?
I've done some testing here just for video editing purposes, and I've replaced, I used to get this, I wish I had it right next to me, I had this little G-Tech little Firewire 800 external unit that had 2 laptop hard drives in it, and it could push, it could basically max out the Firewire 800 connection. So like, I don't know, 60 megs a second or whatever that is. Yep. And replacing those units with 2 little drives in there with a total terabyte of storage, replacing that with one SSD is, it's a phenomenal speed difference. Even though SSD is not great at just streaming a single file, it's more good at random access. It's still for video editing purposes. So I've got to imagine soon for server purposes, for maybe for databases and things like that, it could be huge.
And when we talk about ZFS, we can talk a bit about having a hybrid system where you have a bunch of your physical disks or your regular spinning disks for storage, but then with a ZIL, and a ZFS intent log that's on a SSD. So as the data comes in to be written, it gets buffered to the SSD and then written in a more streamlined fashion to the spinning disks.
A sort of modern day version of what we were just saying those controller cards have RAM on them for.
Yes.
Right?
Yeah, except for,
with other purposes too.
With more capacity. Then, instead of 512 megabytes of RAM, you're talking like a 32 gig or a 128 gig
And really, the complete transaction log is more valuable to have, too. So, that's a pretty good system. Any other thoughts on RAID?
No, I think that's about all we can cover this week.
And, of course, there's tons of stuff in the show notes, too, you guys, so you can go check that out. All right, Alan.
Like Chris said on last, we will cover how to actually do some of this on Linux.
Yep. So we'll cover get your hands dirty on the Linux Action Show coming up. All right, Alan, it's time for the TechSNAP Roundup. All right, Alan, it's time to round up the stories that didn't quite make it into the main section of the show, or ones that we thought you might enjoy if you had a little further reading to do. Of course, every story we talk about, in brief, we'll have links in the show notes for you to read further. And big thanks to the links.techsnap.tv subreddit. Most of these were provided by you guys, and you guys rock, so thank you for that. Now, Alan, the first story on the roundup is another story about smart meters. Now, I remember from a long time ago, we did talk about this one. And now they're claiming through the use of smart meters they can tell what you watch on TV.
Right. Rather than before where they could just tell, when you were watching TV. With this one, they're saying researchers in Germany think that they could actually tell, like if you're watching a DVD, which DVD it was. That the increase and decrease in the power over the time you're watching it would be a significant enough pattern that they could match it up to
This is
a
something
known DVD.
Like they're claiming that based on the brightness and darkness, that'll affect the power draw of the TV, which is true. And
Yeah.
based on those patterns, they can match it. Like, what are they going to pattern recognize a bunch of movies? And then, Jesus, that's creepy.
Yeah.
So that's good.
Yeah, well, it's just, when your electricity meter, your smart meter is accurate enough that it can tell that small of a difference.
Mm-hmm.
And if it's reporting all that data back in real time. Now, most smart meters likely only report aggregate usage features because it would waste a lot of bandwidth to be streaming exactly what your power usage is in real time all the time.
And could you imagine the back-end resources they would have to collect and process all that data?
And store that, yeah.
The database server they would have to have? They'd have to use one of those RAID setups we were just talking about, that's for sure.
Yep.
Interesting enough story, and actually a pretty great write-up over at H Online, the H Security, if you guys want to check that, link in the show notes. All right, I'll cover one about DigiNotar, because DigiNotar, of course, has been the center of a lot of drama lately. They got taken over by the Dutch government, and now they're filing for bankruptcy. They're shutting down. They're going away because obviously all the latest controversies around there.
Well, and specifically since Mozilla and
it's like
Google
we're never
and
going to have
Microsoft all withdrew their trust,
Yeah.
they're no longer a certificate authority, so they're out of business.
Right.
The parent company was also very quick to distance themselves from DigiNotar when it got hacked, let alone now it's going out of business. Like, this doesn't have anything to do with our core product. Our authentication technologies are still secure.
Right.
And so on and so on. They're trying very hard to make it as if this was never even part of their company.
No, that was a completely separate thing, as they always do. All right, next story in the roundup, Alan, was one that you alluded to earlier about Siemens exiting the nuclear power business.
Yep. But again, this likely has more to do with the fact that they're German and the German government has decided not to build any more nuclear power plants. Mm-hmm. But at the same time, it makes you wonder about those, all the nuclear technologies they sold to other countries and the Stuxnet were.
This next story is kind of a funny one because I've been this guy before. A fifth of telecommuters work less than an hour a day, and this is here's coming from the Register. Almost 1 in 5 Americans who work from home only clock in for an hour or less a day, according to a survey, while a third stay in their pajamas. 40% of telecommuters say they work between 4 and 7 hours. 17% are doing the bare minimum, and just 35% are working 8 or more hours. Career Builder surveyed 5,299 people, and they revealed that stay-at-home workers also say that sometimes too much to even be bothered to put their pajamas on.
Yeah. To getting dressed is too much work. So 41% of women and 22% of men stay in their pajamas to do their work all day.
I am wearing a nice shirt, but I'll admit I'm wearing shorts. I'm party upstairs. I'm business upstairs, but I am a party downstairs today, Alan. I won't lie to you. I'm wearing my shorts. That's kind of like pajamas, right?
Yeah, I'm wearing shorts as well.
So we totally fit in with this survey.
Yeah.
We couldn't be bothered. Bothered to put pants on. All right. The next story here in the roundup is yours, sir. And
Alcatel-Lucent has developed a new VDSL technology called vectoring, which is actually based on noise cancellation for headphones that would allow standard DSL lines to carry between 25 and 100% more speed.
Oh, I love this. So this is reusing existing DSL line infrastructure.
Yeah. Now, this is based on the fiber to the cabinet setups. So your ISP has to have enough bandwidth at their location near your street. But most of them do have decent capacity there already. So basically, if you already have 25 or 40 megabit connection, that could potentially go up to as high as 100 with this technology.
How awesome would that be?
Yeah. Well, basically, it'll allow DSL to compete with cable. Mm-hmm. For example, the cable I have here is 50 megabits down and 3 up. But my ISP offers up to 100 down and 5 up, and the best DSL offering is like 16 megabits.
I'd say it's a good sign that it's coming from Lucent, too, because they have a pretty big stake in this market.
Yeah.
All right. Any other thing before we move on? No?
But, it's always nice when since most people's choice is either cable or DSL, letting that DSL choice get up there in the speed and actually be able to compete will force the cable things to be more competitive as well.
Awesome. That
For
really
example,
is good.
here the price of the cable things is kind of ridiculous because you can't get anywhere near that speed on DSL, so it's your only choice. If you want high speed, you have to pay out the nose. And if DSL manages to catch up, that should help drive the price down a little bit.
I hope so. I love it when you can take existing technology and then improve it in a way that you're sort of reinvesting in your existing investments, and that always seems to be like what the market will bear the best. So you can always kind of predict that will actually
Instead
happen.
of having to replace everybody's copper with fiber to their house, you can just get most of the way there on a high-speed network and then make that last 1,000 meters at high speed.
All right, I have one more story on the roundup. Or no, we have a couple more stories, but the one I want to cover next is face palmer. I mean, really, I just want to go like this. HP, as of the shooting of this episode, is considering laying off their existing CEO of only 11 months and replacing him with Meg Whitman. Now, Meg Whitman is the former, and I do mean former, she doesn't work there anymore, she was let go or something like that, former CEO of eBay, and also just recently failed run for governor of California, but was bumped out due to an illegal alien house servant scandal thing. The general tech opinion of Meg Whitman is not very high. And I just look at this and I just think, what the hell is HP doing? You know, what the hell?
Yep.
This company is just lost its way.
And why do all companies seem to decide that their next CEO has to be the former CEO of some other company?
Yeah, I know. Because
now,
the
some
good
of them
ones
are
already
poaching,
taken.
some of them are poaching ones that are still in the position.
Yeah.
But picking up somebody who couldn't get a job anymore, it's just like,
Now, this is interesting. Now, the next story in the roundup is about an iTunes scam. I haven't read about this one. So what's this about?
Well, it particularly came to my attention because we were talking the other day on TeamSpeak. A bunch of people were noticing that their iTunes account had been compromised and somebody bought a bunch of things on iTunes with their account.
Jeez.
And in this case, the Attorney General of Massachusetts had apparently had her credit card stolen and a bunch of charges run up on iTunes.
Oh, that's the wrong person.
Yeah. And well, specifically in Massachusetts, they have laws where when companies are compromised and they lose your personal data, they have to notify you, like right away, right? So if you remember back to the Sony compromise, they had a separate agreement for people in Massachusetts where they had to provide them with like free credit counseling and identity theft protection for a year.
Yeah.
Well, that's because there's those laws there.
Yep.
And so she was never informed that her data was compromised. So it's possible that Apple was compromised or something happened and data was leaked and they didn't tell everybody.
It's also possible that she just had a really crappy password, right?
Right, but there have been a lot of people that have had their iTunes accounts charged for things they didn't buy.
You got to figure
it seems to be a very big scam going on, and Apple's doing its very best to keep it quiet to not lose confidence in iTunes.
Sounds like Apple, right? I mean, and iTunes is got what, like 30 million customers or something like that? Something.
Well, I'm sure it's even more than that.
Is it more? Well, it's the number one music store in the world now, right? Or something?
Yeah,
I mean,
so
it's
it'd have
huge.
to be more than 30 million.
I don't know what it is, but
it'd be a lot. Yeah.
Apple has a very specific interest in nobody finding out about those problems.
Right, but if that's in violation of the law of Massachusetts, then the Governor General wants to know what's going on here.
And how hilarious it is the Governor General of Massachusetts
Attorney General.
Attorney General, right. Who
Governor General is a Canadian thing.
Well, whatever. You know, it's the wrong person to have it happen to.
Exactly.
Now, this last story in the roundup, Alan, this is Pure One, a hosting company that both you and I have used quite a bit, big fans of, and they have a blog post up called The Comfort Zone.
Yeah.
What's this about?
Yeah, basically, it's a charity thing where at the same time as, getting people to stretch their own boundaries, to raise money, people donated, pledged money, and this guy was going to basically rappel off the roof of a building.
Oh, cool.
And, data center tech people like us, I would not want to rappel off the side of a building.
No.
That's way outside of my comfort zone.
Definitely outside the comfort zone, yeah.
And so, it's... also, there was a contest where people could submit their idea of what superhero costume he should wear while doing it.
And he did it. He did it, and we have a video of it, right? If you're watching the video version of TechSNAP, we're playing it now, but we'll also have a link to it in the show notes. This is pretty cool. So
And it was to raise money for children with disabilities.
So he did this as a way to raise money, huh? Well, wow. I've honestly thought about it myself because some of those data centers are just like these sheets of glass, and I have thought probably it'd be cool to Spider-Man down that wall.
Yeah,
He's
well,
just
this
living
is,
out a Spider-Man
I think this
fantasy.
is where their headquarters is, not a data center.
Oh,
But,
okay. It's pretty cool. So we'll link to that in the show notes if you
Yep.
want to watch that. Now, Alan, that's it for the roundup, I think. But we got just a couple of things for Bitcoin Blaster. Our Bitcoin Blaster is usually stocked full of stuff, but for the last couple of weeks, things have slowed down a little bit on Bitcoin. And so we may eventually have to retire the segment if there's not a lot, but we'll keep following as long as some interesting things are out there in the Bitcoin world. And a couple of things caught my attention. I'll give you 3 links this week. First up, just real quickly, is some interesting write-up here by GMA News regarding some findings of Trend Micros and different types of malware that's out in the wild for Bitcoin farming, I guess you could call it, where they infect people through malicious software and either use their machine as just a Bitcoin miner or use it as like a bot and a Bitcoin miner. So kind of interesting. A couple of different things are going on and where to catch those. Another thing to watch is a video that I've put in the roundup of a new mobile payment system, and it's being done at a bar that's going to start accepting Bitcoin as payment. And it doesn't hurt that they've got 2 babes kind of demoing the mobile payment technology, so they show you how you can pay for your beer using Bitcoin and your smartphone. Honestly, my impression watching this is it's a little clunky. You gotta go to a mobile web page, which isn't always super fast to load up. You gotta enter in the different dollar amounts on both ends, I believe. I'm not sure. And then it generates a QR code, and then the waitress scans the QR code with her smartphone off of your smartphone screen, and then she's able to process your transaction that way. And it just seems like I don't think I see the average waitress out there using this. And it's a good step in the right direction, and it's definitely going to work for like a geekier clientele. And that's
but
good.
at some point, if we see waitresses switch their old-fashioned like spiral notebook thing for something like an iPad, where they're taking your order, and it has that forward-facing camera, it could work.
So, this is interesting because, of course, Google Wallet was announced this week, like the chat room's mentioning. Chat room also mentions NFC would make this a lot easier. That's true, I suppose. But it's an interesting note. It's an interesting step in Bitcoin's development, I think. So link to the show notes if you want to check that out. And then the last thing I'll give is one of the best explanations I have found for what Bitcoin days destroyed is. Have you heard of this term, Alan?
No, I hadn't actually.
So this is a new way to measure sort of the velocity of the Bitcoin economy, because one of the ways people have been measuring the trading and the volumes in Bitcoin and then thereby judging how successful Bitcoin is they're analyzing the overall transactions in a day by looking at the Block Explorer or whatever, and you can actually see the Bitcoins moving around from account holders. But one of the things people are pointing out is, well, heck, that could just be me transferring 50 Bitcoins from my wallet to another wallet, right?
Yep.
It would still show up as transaction volume. What you really have to look at is how old and how many Bitcoins are out there to get a gauge of the entire depth of the market. And so by doing some math based on what the current block numbers are and what we know old block numbers are, we can kind of get a feeling for how long those old Bitcoins are going before they're getting spent, which is a truer indicator of the actual health of the economy. Are people buying goods with Bitcoin? Because you can't really always tell that. Also, something you and I discussed last night, Alan, is a lot of times Bitcoin transactions happen within a place like Mt. Gox for a while.
Right. And so we see their transaction volume at like 65,000 coins a day, or in the last 24 hours, but none of those happened as Bitcoin transactions. The money was deposited in Mt. Gox and traded inside there, and that doesn't actually show up as transactions in Bitcoin Explorer.
Right.
So there's that part of it as well. But yes, Bitcoin Days Destroyed looks at blocks that haven't been used in the last 100 days. When they get used, then that's a better indicator that something's actually happening.
This is really interesting, too,
one block
because
getting traded back and forth all the time.
If you look at the data, it actually shows that the Bitcoin volume is going up quite a bit. And it shows we could be reaching a point where we are again in an issue where there's not enough Bitcoin supply to meet the Bitcoin demand. We could be again reaching the point, because right now we've been really walking the line of there's enough Bitcoins on the market, there's enough people buying or not enough.
Actually.
Yeah, exactly. This could indicate that we're about to start tipping the other direction again. Interesting enough, I think it's a term you're going to hear a lot more, Bitcoin Days Destroyed. So
it needs a better term. That term doesn't describe what it is well enough.
I know, I agree. I think that's why it's so confusing. But this write-up is really great. So you can check that out in the Bitcoin Blaster. There you go. Wow. Alan, that's the show, right?
Yep.
Wow. Okay, so next week we're going to continue our home server topic. I think we're going to probably get into file sharing, right?
Yep.
Sounds like it's time to get into file sharing, and we've got a really slick way for you to do that. So you're going to want to tune into episode 25 of TechSNAP to catch that, and of course, all of the other news. And if you'd like to download this episode in just about any format you want, including audio and portable versions and all those things, go over to jupiterbroadcasting.com where you can find the download links and the show notes. And you can also find the RSS feed, so you can subscribe to TechSNAP and get the show weekly whenever we release a new one. Anything else we should cover, Alan?
Yep. No, I don't think so.
Okay. All right, everyone. Well, thanks so much for tuning into this week's episode of TechSNAP, and we'll see you right back here next week.